The next portion of this video is to review physical and chemical changes and physical and chemical properties. Now, we need to discuss the definitions and examples of all of them. A physical property is a characteristic of a compound that can be observed. Now, this means when I'm observing something, I'm using my five senses: what I see, what I taste, what I touch, what I smell. So examples of physical properties can be color, taste, that looks like an F, taste, size, what it smells like, all of those sorts of things. Now, a chemical property is a characteristic that can only be observed during a change. So, for example, if I want to know if a compound can rust, okay, rust, or the ability to rust, would be a chemical property, because I don't know if my bike will begin to rust until I leave it outside in the rain and the water and the air and it starts to rust. I can only observe that that is a characteristic while it's actually changing. Another one would be reactivity. I don't know that something is going to react together and blow up until it happens, right? That's a chemical property. Another one could be, what am I thinking? Rust, reactivity, pH, whether or not it's an acid or a base. Those are things that are chemical properties. Now, a key thing to note is that in both of these definitions, they talk about it being a characteristic, okay? And that is because a property is a characteristic, a quality about it that you can observe, okay? Now, what is the difference between a physical and chemical change? A physical change is a change that results, or a change that does not change the identity and only the form. So, for example, if I cut paper, okay? If I cut a piece of paper, it's still paper. It's just now smaller. I've changed the form, but its identity as paper is still the same. If I fold paper, if I fold my clothes, it's still my shirt. It's still my piece of paper. It's just, it looks a little different. Another physical change could be to, let's see, cut paper, fold the paper. Those are the most obvious examples. You can look in your text and online for others. A chemical change is a change that results in a new identity. Now, most of chemistry, what you would think of chemistry anyway, is chemical change. Anytime you have a reaction, you have a chemical change. Anytime you form bubbles, right? If you add two things together and bubbles or a gas is produced, you have a reaction. Anytime something rusts, burning is huge. If you burn something, it is no longer what it used to be. So if you burn something, like a piece of wood or a piece of paper, anytime you bake, right? Oh, Mixing is a physical change, right? So if I'm using the example of making some muffins, when I'm mixing my eggs and my flour and things like that together, they still retain their identity. But once I put them in the oven and I burn them, then I have, or not burn them, once I bake them, I have now changed them. I can't get the eggs and the flour and stuff back from whence it came. So we have physical and chemical properties, which are characteristics that can be observed, and characteristics that can only be observed during a change. And I also have physical changes and chemical changes. So these you kind of have to pay close attention to when they're asking you for examples. Part of everything that encompasses this deals with the law of conservation of mass and matter. Now, the law of conservation of mass and matter says that matter cannot be created or destroyed. Now, if matter cannot be created or destroyed, you can only have a cycle. If you've ever watched The Lion King, you know it's the circle of life, right? Anything that once we die, we become part of the earth, and then it kind of cycles back through our food, okay? It cannot be created or destroyed. And so that means in a chemical reaction, if you have your reactants, which are similar to ingredients, and then a reaction occurs, like baking, you get your products. When this happens, okay, the mass has to stay the same if the matter is staying the same. So mass here has to be equal to the mass of my products. Okay, for example, if I have the balanced chemical equation, this just shows me that hydrogen and oxygen added together form water. Okay, so hydrogen and oxygen are my reactants, water is my product. When I do this, I can count how many I have. I have 2 times 2 gives me 4 hydrogens, and I have 2 oxygens. When I'm over on my product side, 2 times 2 gives me 4 hydrogens, and 2 times 1 gives me 2 oxygens. I have the same number of atoms in the beginning and the end, which means they have to weigh the same. So even though it might not seem that things weigh the same before and after a reaction, if you have a gas that escaped, right, that can change how much your product weighs, but the mass of the reactants is equal at the beginning and the end. That is the whole idea of the law of conservation of mass or matter. Those terms can be used interchangeably.